cooler to the top end of the prop.
Does everyone remember this video? Maybe that's a dumb question. Does anyone not remember this video? It's gone down in history as one of the Verge's biggest blunders, which they've since taken down from YouTube, but it's been thankfully archived by others. There's a particular part of the story that has always made me wonder, and it's this part right here. See how he doesn't use the final thumb screw to hold down the AIO block? I think he said that he either lost it or didn't find it in time for the product photos. That's kind of a weird excuse, but okay. This made me wonder about the viability of it all. Is 3 screws enough for somewhat even distribution over an IHS? What would temps look like? We're gonna emulate this approach here and see for ourselves in the name of science. Stay with me. If you're looking for a sleek and efficient AIO for your next PC, check out Be Quiet's Pure Loop AIO lineup. Choose between 4 popular sizes that all sport Pure Wings 2 fans and enjoy qualities like dedicated fill ports and decoupled pumps for minimal vibration and maximum aesthetic at the block. Learn more about Be Quiet Pure Loop AIOs below. So here's what's going on behind the scenes. AIOs like this one here transfer heat generated by the CPU via water to the radiator here, where the process of convection and the aid of fans transfers this heat to atmosphere. It's actually called a radiator, but we use convection instead of radiation to get rid of the heat. The idea is to move heat as quickly and efficiently as possible so as to not hinder the processor's performance. And it's important that you mount the block properly, that's this part here, because it determines the efficiency of the interface, which is typically thermal paste. The paste fills in the uneven gaps between the metals in both the cold plate and the IHS and aids in heat transfer, as it's far more efficient than using air alone. Some manufacturers secure their cold plates with only 2 screws and seem to do all right. Granted, they're designed and tested this way. A few still suffer from a bit of uneven pressure distribution over the CPU, but in general it is possible to get away with efficient locking via 2 thumb screws only. Many air coolers in fact do it this way. But AIO water blocks for the most part use 4 screws for mounting to the motherboard, and choosing to omit a single screw entirely can spawn negative consequences for the CPU in question and result in heat buildup. But let's try it with an actual AIO first and see how it goes. To start, we'll run a control and gather temperature data from an ideal model where all 4 screws are tightened firmly and evenly. Then we'll retest by removing the same screw the Verge left off of their build. It's important here that we remove and clean up any thermal paste from the previous run, since the thermal paste needs to redistribute itself with only 3 thumb screws present. And then, just for kicks, we'll repeat the same process once more with only 2 opposing thumb screws tightened down. My predictions, we'll only see a few degree temperature increase by choosing to omit a single screw, and we won't see any additional temperature increase by choosing to omit a second screw. It's a bit of a bold prediction. I'm sure I'll be wrong in at least one of these regards, but I've seen so many coolers get away with only using 2 screws that I think things will still remain fairly efficient so long as the screws are opposing each other. So we're obviously not going to do like to where these 2 screws are still here, then you're just going to have a completely lopsided cooler mount. But if we do opposing screws here and here maybe, that could be interesting. Comment down below with how you think things will fare before we reveal the data. So we rewatched this section of the clip right here, and I realized that his thermal application method is far from conventional. Actually looks like he's drawing a little kind of like a house here. So we're gonna try to do that. I'm gonna try to draw a house. We want to, as best we can, emulate what the Verge had told us to do in that video. So looks, I don't know what the I'm doing right now. I'm just, yeah, all right. It kind of doesn't look like a house anymore, but he was doing little dots everywhere, and well, yeah. I mean, that looks pretty close to what you're seeing here. And then in their build, they forget to connect the bottom left thumb screw. So I'm going to start with the top right. Let's get this one down first. I'm gonna assume that he cross tightened and didn't just like torque the hell out of one thumb screw and then move on to the next one, which is not what you're supposed to do. That will, in essence, force all of the thermal paste in one direction, which is not what you want. Again, you want even distribution across the IHS. Now, as I said earlier, I really don't expect this to change much in the way of temperatures, again, because we do at least have 2 opposing thumb screws that are fairly tight. I'm assuming in their video when he was actually gaming with the system that he still didn't have that 4 thumb screw secured. So if he wasn't seeing any temperature spikes while gaming, I don't think we're going to see anything either in our ID64 stress test. Who knows though? We're gonna find out. Now remember, the point of this video is to only test the viability of 3 thumb screws. We're not trying to emulate the entire build, hence why our cable management is significantly better, even though we spent like 2 minutes cable managing in general, which shows you how lazy they were with that build. We also are running 4 sticks of RAM instead of 2, and they put their 2 sticks in like the wrong DIMM slot. So there's a bunch of stuff they clearly did wrong. We have a video like dissecting that entire video. But in this case, we are only testing 3 thumb screws. And I don't really think it's going to be that big a deal. I don't think it's going to affect much in the way of temperatures at all, which to some might be surprising. I might be totally wrong though. Let's find out. We just started the test and temperatures are already at 90 degrees Celsius. Like, immediately spiked to 90 C. This is going way worse than I thought. There clearly is not even mounting pressure across that IHS, and that is resulting in some pretty toasty temperatures right out of the gate. Hopefully this chip doesn't throttle itself within our hour time frame. If it does, then this is an absolute fail. So that was a disaster. Now what I'm gonna do is remove the AIO, just using a screwdriver here, it's a little faster. Get these 3 thumb screws off, and we're gonna see how this thermal paste was spread over the IHS. I'm gonna pull straight up, and that explains a lot. So Kyle, if you pull in here, you can see that we actually had quite a bit of, a little more thermal paste than we needed, pretty much everywhere across the IHS except for the top right. The reason why the top right went fairly uncovered is because the mounting pressure was greatest over here in this corner. So that effectively pushed all of this thermal paste down to the bottom left. And remember, the bottom left is where we didn't have one of these thumb screws secured. So that makes sense. I didn't expect this to make as big a difference as it did. As you can see, we blue screened, we thermal throttled. The system did not like this. The CPU specifically did not like this at all. Do not do this. And we're gonna do the exact same thing as promised one more time, only this time we are going to omit a second thumb screw. I don't know what the heck they were doing when they applied their thermal paste, but it looks something like this. Just trying to be as redundant as possible. Obviously, consistency is important here, but when you're applying thermal paste as ridiculously as the Verge did, it's kind of difficult to replicate or emulate that over and over. Now we've got the AIO we cleaned off. You can see we cleaned off the cold plate again. We're going to re-sandwich it, and this time we're only going to lock in the bottom right and the top left thumb screw. So this one first. We'll get this one starting to thread, then we'll start threading this one here on the top left. All right, we'll try to tighten these down evenly so that we get an even spread of thermal paste. And only using 2, not advisable, especially when you have the option to secure all 4. These are pretty much as torqued down as they will go. Okay, now you know what would be really mind-blowing, Kyle? Is if this configuration here resulted in better temps than the 3 thumb screws did. I wonder if that's the case, because at least here we have a somewhat even distribution, because what's going to happen is the thermal paste is going to spread across from the middle, like cutting diagonally through the IHS. I think we still might have decent coverage. I'm worried about mounting pressure on the opposing ends where there aren't thumb screws. I'm not sure how that's going to fare. So we've got the AIO reconnected. We're going to install our graphics card again. The only reason I removed that was just so you guys could see a bit better what we were doing in here. And then we'll fire it up, run the same test once more. Who would have guessed it? I was actually right, well, half of the time. The 3 thumb screw scenario performed so poorly that I didn't think removing another thumb screw would make things significantly better. But that's exactly what we're seeing here. And I think it's because of what we talked about earlier, about that even distribution of mounting pressure across the IHS just by having 2 on opposing ends secured instead of 3, where you're kind of forcing all that thermal paste into one corner. Temperatures look awesome, actually fairly close, if not nearly identical to our control run. Mid to high 80s at peak. Right now we're chilling at mid 70s. That's of course with the side panel off. We just took it off for this scene, but still. So who would have thought that if someone had told the Verge all they needed to do was forget to install one more thumb screw, their temperatures would actually be way better. So with 3 thumb screws, temperatures are god awful, and with 2 thumb screws, your temperatures are actually basically almost back to normal. Science is freaking weird. Pretty awesome stuff. I don't advise anyone actually do this. I mean, if you have 4 places to secure thumb screws, use all 4 thumb screws. But worst case, if for some reason your AIO or whatever cooler you're using doesn't have the 4th thumb screw in the box, just forget to install the 3rd one too. And make sure that you secure opposing ends of the AIO to the bracket behind the motherboard. And then at least you'll have somewhat even mounting pressure distributed across the IHS, which is ultimately why our temperatures fared so much better here than in the case of the 3 thumb screw scenario. So that was really cool. If you guys thought this was an interesting test, had a bit of fun watching this video, be sure to give it a thumbs up. We would appreciate that. Look, at this point, I mean, it's kind of like beating a dead horse. It's easy to pick on the Verge video, but we've been doing that for 2 years straight. I've always wanted to come back and test this and just see how bad it really would have been. Again, I'm not sure if the scenes you're seeing here from their video are you know, taking into account the fact that he only has 3 thumb screws secured. Maybe he installed the 4th one before he recorded these scenes, but if he didn't, I mean, his CPU temps had to have been pretty freaking toasty. Consider subscribing if you haven't already. Again, leave another comment down below if you want to see other tests like this conducted in the future, and I'll catch you in the next one. My name is Greg. Thanks for experimenting and cringing with me.